Okay, 1.1 system of equation geometry. Okay, so geometry, geometrically. So we have x, this is y, right? So we have a two equation here, means that two lines. Okay.
Are you writing on the whiteboard right now? Because we can't see anything.
Oh my gosh. Okay. I thought it was making share screen.
It's all right. It's the first day.
First day, yes. Okay, now we are here. Okay, I got it. Okay, so we have two lines there, right? Means the two equations. So we say that this is the solution because two lines met in one point, right? So there's one solution. Okay, now we have x and y in two dimensions. So what if we have two lines, one line like that, another line like this? Okay, is there a solution?
No.
No solution, right? Okay, how about we have two dimension, x and y, and then one line like this, and another line here. Is there a solution? Yes, it is a solution, right? And then we say infinitely many solutions, excellent, right? So we have infinitely many solutions. So system of equation. Okay, let's talk about this then. So we have this x plus y equal to 3 and y minus x equal to 5. So use a graph to find the solution to the following. The system of equation. So we called this is a system of equation, right? Okay, so we have I'm not good in this. Hold on one second. I will make it a little bit bigger. This is more faster. Okay. Okay, forgive me. All right, so this will be like that and like this. Okay, so this will be so what do you think? So we're gonna just use the graph. So solution will be this point, one solution, right? So what will be?
-1 and 4.
-1 and 4 is the solution. Very good. Okay, now. So what if we have 3 equations? So 3 equations. This is from algebra course. So we have one, two, and 3. So how many solutions?
1.
One solution. Good job. Okay, we have that. So we have this one. And we are going to have this one. Okay. How many solutions there? B. We consider, oh,
No solutions?
no solution. Good job. So we consider this is no solution because 3 lines are not met together, right? At one point. Okay, good. Okay. We want to know about the vocabulary, right? So no intersect, then no solution. And I want to talk about the skewed lines. So if you took the calculus 3, right? They talk about the skewed line. That is no intersect, no parallel in 3 dimensions, right? So just a vocabulary, that's all in 3 dimensions. Let me denote like that, 3 dimensions, right? So two lines per to Z. So 2 lines fail to intersect and not parallel. So we have this one skewed lines. Okay, so 3 dimension we have like a equation looks like this, right? So 2x plus 4y minus 5z equal to 8, right? Okay. How about more than 3? So we are using equation like this. X plus y minus 2z plus 4w equal to 8, right? Okay, can you see that more than x, y, z? So in 3 dimension, we have x, y, z. In 2 dimension, we are using x, y, right? Okay. So linear algebra, we are using more than 3 most of the time. And 3 dimension sometimes, right? So linear algebra is good for, we are using more than 3 units. 3 dimensions, right? So we are using x sub 1, x sub 2, x sub 3, x sub 4, and more using that because we don't want to use x, y, z, w, and then what's the next? It's hard to think. Always ran out the variable, right? So we are using x sub 1, x sub 2, x sub 3, x 4, x sub 5, and so on, okay? So that is good for we are using linear algebra. Okay, let us talk about 1.2, algebraic procedures. Systems of equations, algebraic procedure. Okay, so as I said, let me bring screenshot here. So we have a system of linear equation. So definition is here. Let's take a look. So system of linear equation is the list of equations. It depends on how many dimensions, dimension-wise, right? So x of 1, x of 2, instead of x, y, z, right? W, 4 dimension. More, okay? Then we are using just x of 1, x of 2, x of 3, x of 4, x of 5, okay? And other side, we have b sub 1, b sub 2. So we denote it this way. That is a system of linear equation. Okay, we have a in the case is a real number, and b in the case also a real number. And then we have m equation, right? And n variables means they talk about the dimension, right? So think dimensions. Okay, now this one we can express as a summation because everything is addition, right? So summation of, and we are using index a sub ij and x sub j. So j start from 1 to n, and I started from 1 to m. So m equation, we have n variables, okay? All right, so we called this number as a scalar. Real numbers is a scalar. So we are using this terminology. So real number. Also, we are using scalar. Okay, now, another definition. So we have homogeneous, so homogeneous system of equations. So what is the homogeneous equation? So look, this is system from here, right? So system of linear equation. Yeah. Okay. So system of linear equation, we have a b, other side. B is any real numbers, right? In that case, b is the 0. If b is 0 in that case, we called this is a homogeneous system of equation. That is a terminology. I'm gonna ask you. once in a while. Homogeneous. Okay. Yeah. Okay. Now, why we are doing this one? Because we want to find our solution set, right? So, in order to find the solution set. Okay. Now, another definition, we are doing last terminology, right? So linear algebra, like a different language, a lot, like in math, statistics, and linear algebra, okay? Okay, another definition. So let me make it in red. So definition. A system of linear equation is called consistent. Consistent. What is consistent means? If there exists at least one solution. So at least one means we start one and more, right? One or more. It can be one solution. It can be two solutions. It can be infinitely many solutions. We called consistent. Okay, if not, we said inconsistent. Inconsistent. If there is no solution. So this terminology from the algebra course, right? So consistent, inconsistent, consistent, inconsistent, right? Okay, now I'm gonna change a little bit. Find. Find solution of x plus y equal to 3, y minus x equal to 5, right? Okay, how do you find? From the algebra course, we have x plus y equal to 3. We have two unknown variable with the two equations. So negative x plus y equal to 5, right? Okay, so we can simplify, cancel out, this is 0. So we have a 2y equal to, we add them, we get 8, right? So y equal to what? Thank you. 4, good job. And then we can substitute, so back substitute, the back substitution, right? So we can substitute equation number 1 or 2. So substitute into equation number 1. So there will be x plus y equal to 3. So that's how we solve, right? So x plus 4 equal to 3. X equal to what?
-1.
It's a -1. Excellent. So we have solution, right? So x, y, which is -1 and 4. This is how we did earlier. Like graphically, we were finding the solution, right? Okay, so let us do this one. Where we go? This one, right? Same as that. Ta-da-da. That's -1 and 4. Okay, that is the basic concept, right? But then what if we have, this is really easy. This is two unknown variable with two equations, right? So what if we have more, right? So what if we have x plus 3y plus 6z equal to 25. And we have 2x plus 7y plus 14z equal to 58. And 2y plus 5z equal to 19. Still, we can use the algebra course technique, right? Like earlier, right? So we could find the solution, x, y, z. Okay, but then next time we are using linear algebra stuff like row echelon form, or reduce the row echelon form to find out. Okay, so what if we have a more variable? Yeah, what if we have a more equation? How do we do, right? So we are doing that, reduced row echelon form first, and reduce the row echelon form. Okay, so